20 kVA 3-phase star-connected alternator with an impedance of 5 ohms and reactance of 0.5 ohms. Okay, he has given impedance, that is Z is equal to 5 ohms, resistance R is equal to 0.5 ohms. Now what is excess synchronous reactance here? Square root of Z square minus R square, you will get it as 4.975 ohms. From this I can calculate theta, which is equal to delta tan inverse of XS by R, around 84.26 degrees. Okay, what we have to calculate here? We have to calculate maximum power output from the alternator. Maximum power output from the alternator is given as EV P is equal to EV by ZS minus V square by ZS into cos theta. Okay, now what is E value there? E is equal to 12 kilovolts. He has given it as 12 kilovolts. From this I can calculate E phase as 12 by root 3, which is equal to 6928 volts. Similarly, what is V phase? V phase is equal to 11 by root 3, that is 6350 volts. Now what is cos theta value? Cos theta is equal to R by Zs, which is equal to 0.5 by 5, that is 0.1. Okay, now P is equal to EV, E value is 6928 into V is 6350 by Zs is 5 minus V square is 6350 whole square by Zs is 5 into 0.1. So power we will get it as 8 megawatt. What we have calculated here is, this is per phase power. What he has in the question, he has total maximum power output. This is a 3-phase alternator. So P is equal to 3 into 8, which is equal to 24 megawatt is the answer. So option C is correct answer.
Shown below, the switch is moved from position A to position B at a time t equals to 0. The current I through the inductor satisfies the following conditions. I of 0 is equals to minus 8 amps. The rate of change of current at t equals to 0 equals to 3 amps per second. I of infinity is 4 amps. Then find the value of R is. Here E2 equals to minus 2 di by di of t by dt minus IR. So at t equals to infinite, E2 equals to minus IR. So I of infinity is nothing but 4. So E2 is equals to minus 4R. Here at t equals to 0, E2 2 di of 0 by dt minus I of 0 is nothing but minus 8, hence 8R. E2 is nothing but minus 4R, hence minus 12R is minus 2 into 3, which is minus 6, hence R is 0.5 ohms, which is option A is correct. The network function h of s given in the question itself. So find the bandwidth and the quality factor for the given network function. Here we know that bandwidth is nothing but resonant frequency divided by the Q. Here the resonant frequency omega naught is nothing but 1 by under root 10 power 6, that is 10 power 3 radians per second, and the bandwidth is nothing but 300. So quality factor is nothing but 1000 divided by 300, which is 3.3. Hence option
A 3-phase 4-pole 50 Hz induction motor has stator slots as 24. S1 is equal to 24. Rotor slots S2 is equal to 28. Okay, now we have to find approximate speed of the dominant harmonic pole, which corresponds to synchronization with respect to stator. Okay, and speed of the rotor. Okay, now what is stator harmonics here? Stator harmonics is given in induction motor or induction machine as 6 mg plus or minus 1. Okay, where m is equal to integer, from m equal to varies from 1 to so on to up to infinity. Okay, and what about G? G is equal to slots per pole per phase. Okay, how many slots are there here in stator? 24 slots per phase and per pole. Okay, so G is equal to 2. So this is 6 into 1 into 2 plus or minus 1. I can write this one as 12 plus or minus 1 is the dominant harmonics present in the stator side. Okay, which is equal to 11 and 13. Similarly, rotor harmonics is equal to 2 times of S2 by P plus or minus 1. Okay, so this is 2 times of 28 by number of poles is given as 4 plus or minus 1. I am getting rotor harmonics as 9 and 11. Okay, now if you see in stator and rotor, 11th harmonic is the common harmonic we have. Okay, and dominant harmonic in stator is 11, whereas dominant harmonic in rotor is 9. Okay, the common harmonic we have is 11. So the speed corresponding to synchronization is due to 11th harmonic. Okay. Now what is the speed due to 11th harmonic? See, in induction mode in the machines, we have 2 types of harmonics. One is 6m minus 1, another one is 6m plus 1. Okay, if you have 6m minus 1 harmonics, okay, what does this mean? That this is for negative sequence, you can call it as. This is for positive value of sequence. So when you have negative sequence, that means it corresponds to synchronization of minus 1 by 11 ns. Similarly, we have to find speed of the rotor. What is speed of the rotor here? Nr is equal to speed corresponds to 11th harmonic plus speed of the rotor with respect to stator. Okay, so I can write this one as, since relative speed is equal to 0, n relative is equal to 0, I can write it as minus 1 by 11 into ns is equal to ns minus nr by 11 plus nr. So what is this one? From this we can get it as nr is equal to minus 1 by 5, ns is the speed of the rotor. So what is the answer here? Minus 1 by 11 ns and minus 1 by 5 ns. Option C is correct answer. DC machine, okay, which is rotating at 1500 rpm. Okay, that means speed he has given as 1500 rpm, or you can write it as 1500 by 60 rps. Okay, and having a diameter of the commutator as d is equal to 10 centimeters. Now we have to find peripheral velocity of the commutator, that is, let us take it as Vc. It is given as pi d n by 60, where n is in rpm. Okay, so pi into diameter is given as 10 into 10 power minus 2 into speed is 1500 rpm divided by 60. We will get it as 7.85 meters per second. So option B is correct answer. On with list 2.